Hi, Riley.
Hello.
Hey,
Welcome to our interview room. How are you today?
I'm good. How are you? Sorry for the delay. It took me a couple minutes to get in.
Oh, no worries, no worries.
Okay, so as you know, I'm Kayla. I'm the 30 Cares project manager, and I was also the one corresponding with you through the emails. And it's really nice to meet you, Riley.
Yeah, nice to meet you too as well, Kayla.
And I'm Bill Keese. I'm 3D Care's webinar executive, so it's also nice to meet you.
Nice to meet you, Bill Keys.
So we can get right into the interview, but first, this is like a dreaded question, I know, but could you tell us a little bit about what you do at Maker North?
Yeah, so what Maker North does, we do a lot of 3D modeling design, graphic design, and laser cutting design. And we also correspond and do prototype work, 3D printing, laser cutting, basically any sort of small scale manufacturing that you can get done, we can pretty much find a way to get it done. And we try to offer that to the community here in the Sioux and the surrounding region. We've also shipped our face shields out as well to various people around Ontario, and even I think all the way over to Alberta. Some have sent. So yeah, we do manufacture goods like you've seen the face shields and also the ear savers and some other things, and then we also help people get their products off the ground as well.
On the subject of Maker North's face savers and face shields and ear savers like that you were talking about, what kind of materials or filaments are usually used to produce each item?
Yeah, so with our face shields, we initially we had them in 3D printed out of both PETG, which is basically water bottle plastic, as well as PLA, which is biodegradable. It's made from beets and corn, or the leftovers of that process. And then we also had PET sheets, which were laser cut to snap onto the face shield, and then the rest is fabric. Now with the face shavers, those are all 3D printed into PLA. I tried PETG, but that material is a little too flexible. The actual design itself, I designed it so that it would print in one piece. If you know anything about 3D printing, you know that you might need to do support structures to build things if you're trying to make something a little different. So what I did is built in this support structure into the design, so it prints itself. I don't have to do anything really. But because of that, you can't print it at a PETG because the material is too flexible. So I just do it all in PLA, but it's biodegradable, which is great. So I don't need to, you can throw it in the ocean, it'll go away in a couple of years instead of PETG plastic, which will not, you just have to recycle it, right? You can't, it will, it's recyclable at least, but you can't, it's not quite the same. Yeah. As for these face shields now, we did get them injection molded. So we initially had them 3D printed, but we couldn't meet the demand as quick as we wanted. So we got 6,000 of these face shields made from a partner of ours down in Parry Sound. And those are made out of high density polyethylene, which is a common injection molding plastic. It's not biodegradable, but it's recyclable. So that's good. And it makes it a little bit quicker for us to get these out. So now we could ship these things out by the hundreds, and all we have to do is assemble them. And it's a lot quicker than having to 3D print them on all our machines.
Wow, that's really cool. I didn't know that some of them were biodegradable.
Yeah. So essentially, most of the PPE was made with plastics, correct?
Yeah, all the PPE is made out of different various plastics, and we try to keep to recyclable and also biodegradable plastics. You can print nylons and ABS and different plastics, but we try to avoid those and stick to the biodegradable and recyclable stuff. So it's better for the environment that way.
Since each piece of equipment was mostly made with the plastics, would you say that 3D printing PPE is mostly cheap? And if you're comfortable, could you give us a rough estimate of how expensive it was to produce the face savers and the face shields?
Yeah, I don't think I can run through the cost it is to make it, but I can tell you that the plastic itself is pretty cheap. And if you buy a 3D printer, it's pretty nice that you can sort of prototype on the fly. So what's nice about this versus, you mentioned injection molding. The thing about injection molding is that you make it once, and every change you make, it's a metal mold they use. With 3D printing, I can just make a change. So for me, I went through 7 different prototypes in a matter of 2 weeks. and was
Wow.
able to finalize that and get it to the market within less than a month. Whereas with injection molding, it might take me a month or two to even get something going. So
Oh,
it is cheap though. We charge the unit cost we sell them for is $5.99. So we try to keep it
Mhm.
fairly reasonable. Face shields are more expensive, but that's, I mean, they have more plastic. What's cool is that when you 3D print the thing I made, we designed that one in house, and we try to keep it as minimal as possible. So the only thing's only 5 grams in plastic. Some of them are 3 grams if you print it in different plastics, and it's fairly quick. It only takes a half hour to an hour to print one. So that might sound like a long time, but it used to take us 3 hours per piece of plastic to print a face shield, and we had 15 machines going. So we were running
wow.
24 hours just to make by at the beginning of the pandemic. So we do about 100 a day. But with the injection molding, we got it to, now we can just meet the demand that is needed for the community.
Yeah.
3D printing is fairly cheap. If you bought your own printer, a spool might cost you $30, and you can get, I mean, this particular design I made, you can get probably 100 of them out of one spool. But there's a little bit more to it than that, because you have to make sure you maintain your machine. There's a lot of learning involved. So a lot of people have a struggle when they first get into 3D printing. So it's nice with us, we kind of just know what we're doing at this point, but it took us a little to get there.
Yeah. So that's like really great. And it's just like incredible how something so cheap and so quick can like help fight against a literal pandemic.
Yeah. Like we try to be reasonable with these things, and that's the thing. Even with the face shields, they're $15,
Hmm.
and we try to make it reasonable. I've seen there's other companies in Canada that sell face shields for easily $20 to $30 and more, just because they probably can, and I'm sure we could too. But we wanted to help the community and keep something reasonable and make it so it's affordable and not so overbearing, just to protect yourself, right?
Hmm.
So
Yeah.
and the face savers have been pretty fun. They've been a cool little project for me anyway.
So in terms of the 3D printers that you use to make each device, would you say they're more like equipment suitable for beginners, or like that can be commercially bought, or are they more like expensive large scale printers?
Well, we have a mix. So we have a few of
Mm-hmm.
our original printers that we bought when we first opened, which were, your standard, we call them Wanhao i3 printers. They were just, the standard printer you might buy. At the time, they were like $400. Now you get them about $600 to $800. So
Mm-hmm.
they're fairly cheap printers, but they're bulletproof. They last forever.
Wow. Yeah.
And now we have some more expensive printers, some that cost about $1,200, some that cost $3,000, that are, pretty expensive. But what the main difference with 3D printing is that each machine, you basically pay for the quality of your parts, right? So, if I buy a $3,000 printer, its parts are very heavy duty. They last a lot longer. When I buy a $500 printer, I might have to switch the parts out every month or every 3 weeks, every 2 weeks maybe. Whereas you buy a very expensive printer, and it might last you a year before you have to fix anything on it. So that's the main thing you get. But the thing is they're all 3D printers. They're all CNC machines, and they all do the same thing. So even if you could get by with a $500 printer. If you know what you're doing, once you learn how to fix them and keep them maintained, you can upgrade those things like we have. Our first 5 machines were like that. You upgrade them and they're great. They run fine. You don't need to have a $3,000 printer to be able to prototype out and make stuff. It helps if you have that printer to get higher
Mhm.
quality and more advanced printing features. So
Yeah, that would be really interesting to see like everyone in the future like producing their own PP at home with a 3D printer, like similar to how everyone like prints documents with their own inkjet printers at home, like
yep.
almost have that same kind of standardization. I think that's really cool. But in your opinion, do you see 3D printing as a public accessible technology for producing face masks and shields, like especially moving into the future with COVID?
I think it's definitely. I mean, right now we're at the point where I like to compare 3D printers to floppy drives because right now they're as advanced as they are. They're very simple machines right now. I'm excited to see what the next 10 to 20 years comes out, 5 years even. They advance these machines very quickly. When we first got them 3 years ago, they had manual leveling with little screws, and now these machines have little sensors, and they just auto level themselves, and you press play, and you don't have to do anything on the expensive machines. They'll just run themselves, and you might have to tweak them every once in a while. But the more expensive machines are getting very fancy, and it's cool to see. But the basic technology is still the same, and there is failures. Things you have to learn things. You have to learn how to use the slicer. You have to learn how to 3D model. There's lots of learning. It's not quite at the point yet where someone could just buy a 3D printer and just do something. But it's close. A lot of the expensive machines, like a dentist might buy a $3,000 machine. A lot of dentists will do that they'll make dental parts with that. And those ones are pretty simple. The expensive ones, you can just print to it and they'll just kind of run. And that's where it is very accessible. You just have to be a little patient with yourself on the learning end because it's not quite there to the point where you could just press play and it works. A lot of times you're going to have it fail 5, 10 times or 20 times before you figure out how to get it to work. So that's the thing. But yeah, they're very accessible. And anyone that's interested in learning about it, we used to teach here before COVID happened. And, I used to teach 3D printing and laser cutting, teach the community how to run these things. And I taught a lot of people around here how to do it. And they go and make their own things all the time. So it's definitely accessible. It's just, there's a little bit of learning still. It's not quite the thing you can just do without thinking, but I'm sure it'll get there.
So we've seen on Instagram that Maker North has donated face shields to the Sioux Area Hospital. Yep. And that's like really cool. And we applaud your company for that. But we'd also like to know if there were any challenges with mass producing those face shields.
Yeah, when we did do high volume at the beginning, and what we had to do is we actually upped our machines, so we bought a couple more machines to help the demand. We had every machine going nonstop, about I'd say 18 hours a day. We had myself as well as my a coworker of mine and my boss Joe Bertrand.
Yeah.
We would be cycling in at different hours of the day to keep the machines running. And we'd do about 100 a day, and sometimes less if we had failures. But we were able to meet the demand for a bit, but we were a little slow on the timelines. It was hard to get things quickly. It'd be sort of if someone ordered something at the beginning of the week, it'd have to get to them near the middle or end, which is quick enough. But when the pandemic was rising and people were going crazy trying to get these things, it was hard to meet that demand. It really was. But the injection molding helped that. And now we're at the point, like you said, where it's a little bit easier. But it's still, we still have, it takes us a bit to assemble the things still, and I have to bag them. So there is even though they're injection molded, it's still a little time consuming, but yeah, it's been good. They trying to maintain it. I'm glad we switched over because it was hard on the machines, really. But funny enough, there's lots of people that do it. The company Prusa, they make 3D printers, and they actually have the largest print farm in the world, and they actually 3D print their own 3D printers, basically, for the most part. So they'll have 500 3D printers, 3D printing more 3D printers. And they sell the parts, not the metal parts. Obviously, it's stuff like that you can't 3D print, but all the plastic parts that are made on those printers are done in their shop by other 3D printers. So it is cool. It can be done. You just need a lot of them. It's just very scalable in that sense. The thing is if I tried to print 10 of one thing on one printer or printed one thing on 10 different printers, I'd be able to get my workflow a lot quicker because injection molding is one of those things where you can just, it's better in high volume, but 3D printing, it only goes one at a time. And because of that, it doesn't work very well for quick printing because unless you have a lot of machines. So, and that's what helped us. We were the only one in Northern Ontario and probably that could do this really. No one There's a couple stores in Toronto that was doing the same thing as us that sold 3D printers where they were 3D printing them nonstop. But really around us, or for us around here, there was really not anyone with enough 3D printers to meet the demand. We were the only ones that could do it. With the face shavels, we're not going to injection mold those unless the demand meets it, gets to that point. But we can 3D print those things a lot quicker because they're smaller. I can make 100 of those in a day or two, really, between all my printers, it's really cool. So it really depends what you're making, but it can be pretty scalable.
Yeah.
So
Yeah, that's really great. But it's like kind of unfortunate that 3D printing can't sort of, I guess, replace traditional
not yet.
injection
Getting there.
molding.
It's getting there. Not yet, but it's
Yeah.
almost there. There are some pretty advanced 3D printers out there, that are industrial grade that can meet those demands. But they're out there. But those are primarily in the aerospace fields and car manufacturing, things like that. Those aren't really there for the masses yet, but they're out there. You can 3D print aircraft grade parts on 3D printers now out of steel, but you just have to have the right machine. But in terms of a standard 3D printer that you might see on online on Best Buy, you can do it. You just need a lot of them. That's all. If you want to do it, you want to print 100 face shields in a week, you buy 30 printers and you do it, or 10 printers, you could do it easily. And if you have one 3D printer, you could easily meet us local demand. You could, if you have it nonstop printing and it's a big enough printer, you could probably do 10 a day, really, on one printer. I actually posted the face shield or the face saver design online for people to use. If someone has a 3D printer and they want to print one, it's online and available on Thingiverse.com.
That's really great.
So we did try to put that out there for the community. So if they want to sort of try to outsource and get their own help, then they can. So.
Yeah. So considering your experience with the amount of face shields that your company has produced for the Sioux Area Hospital, in your opinion, would you say that 3D printing PPE is cost, time, and quality effective?
Yeah, I think you can really help the community in a fairly efficient way with 3D printing. Really the benefit now where 3D printing does shine is with prototyping and rapid prototyping. So for a guy if you just want to make something and continue to improve it, I can continue to improve anything I make that's 3D printed. If someone has an idea and I wanted to change it, I can make that change and start printing them the next day, which you couldn't do with my face shields that are injection molded at this point. So it's nice that 3D printing is good for that type of thing. So we can really help with it. And I think it is efficient. So
yeah, so like you mentioned, like it would probably be the most feasible manufacturing type for dealing with unexpected challenges in the healthcare world, like COVID-19. I think it's very timely, right? Yeah.
Yeah, I think it's quick in getting the product out there. Really, like without being able to prototype your thing with a 3D printer, you're really not going to get it out there as fast. Unless maybe you're I don't know, Husky Liners and you're have an injection molding facility and you're a huge company. Unless you're one of those, you're not going to help the community without a 3D printer that quickly, really. Because even those guys took a while to get anything off the ground. I mean, we were 3D printing face shields before any of the big guys were doing it, because we had 3D printers. So we started right away, and then we helped as many people as we could. And all we did is make it easier for us to continue on doing other things as well by injection molding, really. Now I can do other things like the ear savers, face savers. We can do custom laser cutting, engraving, custom 3D printing. We can do all the custom stuff again and still sell face shields to the community. So that was the main benefit of the injection molding, is that we can outsource our tools to other things, but and still help the community. So.
All right, so we're almost near the end.
Yeah.
So I think this is the last question. Would you say that 3D printing PPE allows for more flexibility in materials?
Yeah, there's definitely a lot of, you could do a good amount of materials with injection molding as well, but there's tons. I mean, I can print flexible stuff with a 3D printer easily as well. I can do, I can print carbon fiber, I can print nylon, polycarbonate, ABS, all these different plastics that are available, and they're accessible too. I mean, there's challenges with everything, right? Injection molding has its own challenges. 3D printing has its own challenges. But once you know how to use a 3D printer, you can really get your ideas off the ground quickly. And that was where we benefit. At the beginning of the pandemic, someone already made a face shield, and we started printing it and started helping out the community. And then we made our own design and got that off the ground. We started printing those, and then we started injection molding. And that was only the large scale, really. When I say large scale, I mean thousands, right?
Yeah.
To print thousands of those, it is far more efficient to do it with injection molding, unless you have lots and lots of 3D printers. But if you're trying to help, it's way quicker to print, even 100 a day for a while than it is to wait months and months just to get a prototype off the ground with injection molding. So I think 3D printing is perfect for this type of thing, and we've been helping, and so have other people, and it's been great.
So the biggest benefit would probably be turnaround time then,
that turnaround time in terms of getting things, definitely, and the flexibility of materials, like you said. I mean, I can print lots of different stuff, and if you want to do something for the community, it's really helpful to do it in an efficient way, and that's what 3D printing helps doing. So it's awesome. I think it's a great technology. I know I know its flaws, like everything has its flaws, but it's really something else to be able to just make anything that you want, really, and have no limits to that for the most part. It's crazy. It's all the things I've made. I don't even know all the crazy things. People ask me to make stuff all the time, and I can just make it on the fly and offer it fairly reasonably costed to the community, which without a 3D printer, you can't really do that. You can't cheaply get injection molding done. That's the main thing. I mean, you're talking thousands of dollars. You're not talking hundreds, right? It might cost you $100 to 3D print something that's huge, or a couple hundred. But if you want injection mold, you can't do it for less than 1,000 units. And then 1,000 units is a lot of money. So you need to have capital. So to do a lot of them, I mean, to get into world scale manufacturing, with a traditional 3D printer, you might need 500 of them, which sounds like a lot. That's what Prusa does with their 3D printers. If you look them up, Prusa Manufacturing, they have lots of 3D printers. 3D printing, it's called a print farm, is actually what you'd call it. That's the terminology for that.
Yeah, we actually came across Prusa when we were researching.
Yeah, and that's actually how they're the ones that helped us get the initial face shields off the ground. That we used their design to initialize the help, right? Just to start helping the community. We use that, and then we developed our own so that it's better off for ourselves. But it's really it's really something, though, what I see with all the different 3D printers out there. You got metal ones now that are really crazy. That would be called SLS manufacturing, and it's tons of different things you can do.
Yeah, all of us on our team are definitely hoping 3D printing takes off even more in the future. And in terms of making medical grade PPE, we hope that your PPA at Maker North is like a huge hit, because we're really excited about it.
I'm glad. I hope for the future too. I think there will be tons of innovations. I know there will be with 3D printing, and it's going to get to the point where it will challenge injection molding at some point.
Oh wow!
It will. It just might take a while, but it'll happen. It will. I know it. It's just one of those things.
Thank you so much for letting us interview you, Riley. It was a pleasure, and our team at 3D Care can't wait to see the new 3D printed innovations that Maker North comes up with. and just have a great day.
Thank you. You too.
Thank
Thanks
you.
for interviewing. It's been great.
Yeah, it was great talking to you. Thank you.